In this video, we are continuing our Quiz 5 review, and we'll look at valid versus invalid arguments. So recall that an argument of the form, so I'm going to write the propositions that were given first. I'll call one of them P1, next proposition P2, ... up until we get to PK. So these are all of the given propositions. So if we're given these, and then I write therefore, these three dots mean therefore. Therefore Q, so Q is the concluding proposition. So our argument has this form, and this argument is valid. If we look at the proposition P1 and P2 and ... and up until this last given proposition, PK. So if we look at all of those implying Q, if this is always true, and we will use a truth table to verify this. Use a truth table to verify this. Alrighty, so let's look at a review example. So this example says, convert the following argument to symbolic form and then determine whether it is valid. So the statement says, I pull an all-nighter and miss my first class, or I sleep early. I decided not to sleep early, therefore I miss my first class. So I want to begin by having you pause the video for about 4 minutes to try this one on your own first. 4, 3, 2, 1, pause it and try it on your own for about 4 minutes. Alrighty, so hopefully you did that. Hopefully you paused it for about 4 minutes to try this. So I have this statement in words. I need to convert this to symbols. So let's label our propositions. Okay, so looking at this first sentence, I see that there's this matter of I pull an all-nighter. So let's label that. I'm going to maybe call that A. A is going to be I pull an all-nighter. Okay, and then after the and, it says miss my first class. So maybe I'll make that M. M is going to be I miss my first class. And then after that, after the word or, it says I sleep early. Maybe let me call that E. I know I'm running out of room here. I'm going to move this to the next page. So it says I sleep early. I sleep early. I'm just keeping it here for the time being so I can still look at this sentence before I move it to the next page. Okay, and then after that sentence it says, I decided not to sleep early. I don't need a new letter for that because that's just going to be the negation of E. And then there's the therefore portion. I missed my first class. I don't need a new letter for that either because that's one of the things that we already have. It's M. Okay, so let's continue this on the next page. All right, so I've just copied down these propositions on the next page. Now that we have that, let's form the argument in symbols or in symbolic form. Okay, so let's go back to the proposition and what it said. All right, so going back to the first sentence, it says, I pull an all-nighter and miss my first class, or I sleep early. So I see two operators there. I see the word or, and I see the word and. So one of the things I need to know is which one's sort of like the main operator in that line. So the fact that it has this comma here, and then it says, or I sleep early, tells me that the main operator is that or. So let me write that. Okay, so I'm going to write an or operator. And then before that, I'm going to put a parentheses, because before the or, I have this and statement. So within that parentheses, I'm going to need an and symbol. So let's put an and symbol. And what were the two things that go in the and symbol? Well, one of the things was I pull an all-nighter, which is A. And the second thing was I missed my first class, which was M. And it was then or I sleep early. So it's or E. So one of the sentences was this proposition. The next sentence says I decided not to sleep early. So that's going to be the negation of E. So I will have the negation of E. That's the next proposition in the argument. And then we had our therefore. So 3 dots for therefore. Therefore, I missed my first class. So that's going to be M. Okay, so that is my argument right there. So now we have to test its validity with a truth table. I wanted us to see if this is a valid or invalid argument, and we're going to test that with a truth table. Alrighty, so let's give ourselves some room here. So I'm going to need 3 sort of simple propositions to build this. I'll need A, M, and E. And actually, before I go to the truth table, I need to build the proposition that I'm going to check in the truth table. So I'm going to check if, so I got to take all of the given propositions, so these ones are the givens, and make a big old and statement out of them. So I have to check if A and M or E, and then combine that with, and that with, not E. I got to make a big old and statement with all of them, and then make that whole thing imply M. I need this to be a tautology. And a tautology just means it's always true in the truth table. Oh, tautology, I need this to always be true. Okay, so now for that, I'm going to start to build my truth table. So I'll have A, M, and E. Give myself a lot of room, double vertical lines. I'm going to do this truth table a little bit more quickly. Okay, so I'm going to have a column for A and M. And then I need A and M or E. And then from there, I can do not E. And then I could combine those. Oops. And then do A and M or E. And then do that with not E. Alrighty. So let's put a vertical line. And then finally, I got to do that whole previous thing, implying M. So I got to do A and M or E, big old parentheses, and not E, big old bracket, and this whole thing implies M. Okay, so I'm going to do this truth table a little bit more quickly because we just did a truth table review video, and we've done a bunch of truth tables. So hopefully we're getting more and more comfortable with these. Alright, so I've filled out the first 3 columns already. So for A and M, the only way for a conjunction like this, an and statement, to be true is if both A and M are true. And that happens in the first 2 rows, but the rest are all going to be false. It's all going to be false. And now I got to make an or statement with the previous column in E. The only way for an or statement to be false is if both of those columns are false. And that happens in this 4th row, this 6th row, and that last row, but the rest are all going to be true. Not E is going to be the opposite of E, so I'll get falses here, and the rest are going to be true. And now we're going to make an and statement involving the previous 2 columns. The only way for an and statement to be true is if both of them are true. That happens in the 2nd row. And I believe that's it. So the rest of those rows are all false. I'm going to put a bunch of falses. Bunch of falses, bunch of falses. All right, and then this final column, it's an implication where the first part of the implication is this previous column, and then the second part of it is M. Okay, the only way for an implication to be false is if the first part is true and the second part is false. So the first part of the implication is only true in this 2nd row, and M in that 2nd row is true, so that makes the implication true. Okay. In every other row, the first part of the implication, this whole thing is false. And if the first part of the implication is false, the whole implication is still true. Okay, so we're going to get a bunch of trues in all of these. Alrighty, so that is exactly what we wanted. The outputs are all true. So I got to write that as a conclusion. So since A and M, or E, parentheses, and not E, big old bracket, this whole thing implying M is a tautology. In other words, it is always true. That means the argument that we were looking at in this question is valid. And that is our answer.